Good morning, everybody, and welcome to the ERCI webinar. We are talking today about norms and standardization for trackside equipment. My name is Lutz Hübner from Berlin Partner for Business and Technology. We are one of the managers of the cluster Transport, Mobility and Logistics in our German capital region, Berlin and Brandenburg. We are one of the members of the European Railway Clusters Initiative, and that is the first thing I want to do. To introduce you the European Railway Clusters Initiative, ERCI. We are a network of 17 railway clusters covering 16 European countries. ERCI was founded in 2010, and it's a legal entity based in Brussels since 2022. We are covering over 2,000 companies, of which 1,500 roundabout are small and medium-sized enterprises, which are managed by the regional focus clusters. We are covering also universities, R&D organizations, education institutions, incubators, accelerators, etc. About ERCI, what are our services? We are mainly working for small, medium-sized enterprises, enhancing their visibility on European level, and encouraging partner matchmaking in research and development projects. We are supporting them and be more visible and be to discover international markets and find proper partners for their business. We are dealing with innovation topics due to an instrument called ERCI task forces, and some of the innovative topics which are interesting for the future railway systems are cybersecurity, multimodal and logistics, and green and sustainable mobility and human factors. We want to show how innovative small, medium-sized enterprises and other institutions in our ERCI regions are. Thus, we are organizing bilateral workshops and webinars such this webinar. And our yearly highlight is the annual ERCI Innovation Awards. There is first a regional stage and then the European stage. And every member of every ERCI cluster is able to, if it is an enterprise, to apply for the ERCI Innovation Awards. And every ERCI cluster has a possibility to choose a maximum 3 candidates to delegate them to the European contest. The awarding ceremony will take place in Berlin this year during the InnoTrans in September. So you can reach us through several media, via internet, via X, via LinkedIn, and so on. I will do the main hyperlinks into the chat, and will now hand over to my colleague Guido from DTEC Fair. He is introducing the first presentation.
Thank you, Lutz. Good morning, everybody. I'm representing DTEC Fair, the Italian railway cluster, and today I'm glad to present you some words about the first speaker, Dennis Galli from ACM Progress Rail. He is the manager of the testing and metrology laboratory. He mainly deals with the calibration of the instrument and the execution of each test on the signaling equipment, including type test. Since 2015, he has been designated by its company to represent it within the CEI, the Italian Technical Committees of Interest in the Rail Sector. Progressively, from 2019, under the pressure of CEI, he became part of as a technical expert of some Senelec working groups. And since the end of 2021, he has been appointed by the member state as convener of a working group for the drafting of a new standard, which will deal with type test for ground signaling equipment. And this is one of the topic of this webinar. Dennis, the floor is yours. Thank you.
Okay, thank you. I share my screen. Okay, can you see my screen? Yes, perfect.
Yes.
So, good morning to all. I'll present something new in the normative area for signaling and telecommunication equipment to be installed at the Trackside. Okay, before to start, I would like to present my company. From 2018, my company, previously ECM, was acquired by Progress Rail, an American company, part of Caterpillar. And Progress Rail managed the transportation market sector of Caterpillar. Mainly, Progress Rail operates in two business segments, rolling stock and infrastructure. Our headquarters is in Alabama, USA, but we are about 8,000 employees spread over 19 countries worldwide. As I said before, our core business is divided in rolling stock and infrastructure. In particular, my company, Progress Rail Signaling, located in Italy, in Pistoia, near Florence, is focused on the design and installation of signaling equipment to be installed on board or trackside, and power equipment always for signaling. A little bit of story of my company. So my company was born in 1958, and like many Italian companies, it started from a family. Cappellini's family, formed by two brothers, Mario and Roberto Cappellini, and his father. From the design and production of transformers for industrial or domestic use, ECM started to work with the owner of the railway infrastructure in Italy. Over the years, it has always tried to adapt to what the market required by moving from transformers to complete power system designed for railways. Since 1990, the company began to design and manufacture its first signaling product, first with the LED signal, and then with the various ATP system, both trackside and onboard train, culminating in the design of our computer-based interlocking. As I said, in 2018, ECM becomes part of Progress Rail, and in 2022, permanently becomes Progress Rail Signaling. In addition to our product, so computer-based interlocking, ERTMS, wayside and onboard, LED signal, and power supply, we manage with our engineers the complete project so as to give a turnkey solution to the customer. These are part of our certification and membership. In addition to ISO 9001 quality certification, we have certification for the environmental management system and certification for the safety management system. In addition to the national association to which we are member, I would like to mention Unisig, Unife, and Ditecfer, the Italian cluster part of ERCI. As Guido said before, in Progress Rail, I manage the internal testing laboratory, but considering the scope of the presentation in this slide is presented my role in the standardization bodies. So I have the role of a company representative at CEI, the Electrotechnical Italian Committee. I participate as a technical expert in various working groups regarding EMC, the 50121 series, a guide to the use of the EN 45545-2 and -5 for electronic equipment on board of rolling stock, the revision of EN 50125 series for the environmental condition, and the EN 50155 for electronic onboard equipment that I think that you know. At the end of the 2021, I was nominated as convener, leader of the working group that have to draft a new standard for type test for signaling and telecommunication equipment. Main scope of this presentation. So, Before to enter in the core of the presentation, I start with a little bit of information about the world of the standardization that can be new for everyone, for someone. The regulation 1025 of the 2012 regarding European standardization identify for the Europe the European Standardization Organization that can write technical standard and harmonized standard. In particular, in Europe are CEN, CENELEC, and ERCI. What is an harmonized standard? An harmonized standard means an European standard adopted on the basis of a request made by the Commission for the application of Union harmonization legislation, or in other words, a technical standard that with its application give the presumption of conformity to the essential requirements of the related regulation or directive. CEN and CENELEC, national member, are national standardization body for CEN or the national committees for CENELEC of the 27 European Union countries, plus United Kingdom, the Republic of North Macedonia, Serbia, and Turkey, plus 3 countries of the European Free Trade Association, Iceland, Norway, and Switzerland. For each standardization body, there is 1 member per country. The relation between IC and CENELEC and ISO and CEN. In order to avoid the duplication between standardization at international and the European level for the benefit of the contributors and the user of standards, and to increase the efficiency of standardization at European and international level, CEN and CENELEC have signed agreements with their respective international counterparts, the International Standardization Organization, ISO, and the International Electrotechnical Commission, IC, setting out the rules governing cooperation. In particular, Vienna Agreement signed in 1991 between CEN and ISO, and Frankfurt Agreement signed in 2016 between IC and CENELEC. This agreement aims at the simultaneous recognition of standards at the international and European level through improved exchange of information and mutual representation at meetings. CEN and CENELEC, or ISO and IC, take the lead in drafting a new standard, but the related document will be submitted for simultaneous approval by both. In this way, international members can influence the content of the European standard and vice versa. The actor in the standardization. So, in the technical committee of the CEN and CENELEC, responsible for the standard development, participate, as I said, the national member, and can participate the members of the European organization like ERA. National members with their stakeholder as industry, certification body, or consumers participate actively. The member of a European organization can participate in the technical committee and contribute to the work. They can give advice, but they cannot vote. From the market need or by the European Commission, if requested an harmonized standard, can arrive a standardization request. The competent technical committee analyze the request and decide if the request can be fulfilled or not. Then the body in charge to write the standard is the working group nominated by the technical committee. In particular for CENELEC, this is the 3 decision layer: the technical board, the various technical committee, for example, for railway, power transformer, electric cable, etc., and the related working group. In the next slides, the role of the different actors will be explained in more detail. The technical board is the body which controls the full standard program of CENELEC, approves CENELEC technical policies and strategies, examines and decides on proposal for new work item, and approve the technical committee business plan. Technical committee are established by the technical board with the precise title and scopes to prepare CENELEC deliverables, and it is responsible for that. Considering the range of the scope of application of the technical committee and when different expertise is needed for different part of the work, the technical committee can establish subcommittees. For example, TC9X, the technical committee for railway, has within it 3 subcommittees: SC9XA for communication, signaling and processing systems, SC9XB for onboard equipment, and SC9XC for fixed installation. Working groups are formed by individual experts appointed by Senelec national committees, and their job is mainly to draft and set up the standard, considering the input of the related technical committee. So, what I've just explained is only to give you a quick idea about the world of the standardization in Europe, but if anyone would like to go deeper, the best things to do is to visit the Senelec website, where all of this information is publicly reported. Now we can enter in the core of this presentation, and first of all, it's important to answer to this question: why we need to have a new test standard for railway and signaling and telecommunication equipment installed at Trackside? So we need to analyze the state of the art. Now, no product standard exists that specifies the test requirements for signaling and telecommunication railway equipment installed at Trackside. Instead, for onboard equipment, EN 50155 applies. Except for EMC aspect covered by the relevant Senelec standard, each European member state, customer or manufacturer applies its own procedure for testing equipment. In some cases, these procedures have similarities, but usually they diverge for particular test requirement or other aspects. EN 50125-3 is usually considered as a product standard that applied through Europe. However, this standard doesn't describe testing procedure to be applied. This fact leads to difficulties for the manufacturer supplier to demonstrate at the European level the compliance with the environmental condition and parameter specified by this standard. As I've just said, EN 50125-3 provides environmental condition defining classes or expected value for signaling and telecommunication apparatus installed at Trackside. Currently, no standard exists with a complete set of procedure and/or prescription to prove that an equipment fulfills all or most of those environmental conditions. To prove compliance with certain requirements, both basic standard and product standard are available. This is true, for example, for EMC requirement, for which EN 61000-4 series basic standards and EN 50121-4 product standard are applicable. In such cases, how to test an equipment is fully described. For other aspects, the same coverage doesn't exist. For instance, for temperature, humidity, and vibration, there are some basic standards related to test procedure, EN 6068 series, but no one prescribing the type of the test required, the duration of the test, or the possible sequence of cycles. In these cases, the supplier can only comply to the customer technical specification, if any. But if he wants to sell the apparatus to another client, the test method may not be recognized as valid due to small difference, for example, duration of a climatic test, forcing therefore the supplier to repeat the test, which costs time and money. In the event of absence of a customer technical specification, this procedural lack forces the designer to carry out tests following their good practices, but there is no guarantee that it is sufficient. For some requirement, there is no direct relation with a basic standard to prove the compliance. This is the case, for instance, of the snow, hail, ice, and pollution. In these cases, the approach normally used is a project verification analyzing the used material and the design choice. In summary, If there was a standard with a comprehensive list of test procedure, prescription, or analysis procedure to ensure that existing requirements are met, it could be used profitably by all the involved parts during the apparatus homologation phases. So what is the benefits? There will be benefits for all stakeholders, such as designer, manufacturer, assessor, operators, and authorization bodies, because we have the same standard. This to allow the supplier to match without ambiguities customer requests all along the Senelect market. And of course, less time to reach product conformity because the rules are clear and the same for all. So I think that you understand the importance of this standard. Now only 2 words about the standardization request and the progress status. In January 2020, I submitted the standardization proposal to the Italian Electrotechnical Committee, and after about 2 years, the actual drafting phase began. Now the work is ongoing, and we have done about 80% of the standard. The deadline for the inquiry stage will be in August, but we plan to deliver the draft earlier. We hope in May. And as can be seen on this slide, the effort was and is very important to the expert of the working group. An important information that I want to give is that this time not paid by Senelec should be seen as an investment for companies, because being on the front line during the drafting phase and knowing in advance how the standardization landscape evolves give to the companies an important advantage. So now I would like to share with you the highlights of the new standard called PR-EN 50736 Railway Application Communication Signaling and Processing System Test Requirement for Signaling and Telecommunication Equipment. The introduction that is an informative part of the standard specifies that the document contains test requirement and performance acceptance criteria for most of the mentioned environmental conditions published in EN 50125-3. Furthermore, it clearly indicates for which environmental condition no test methods are known, and therefore no meaningful test requirements can be defined. Test requirements for the type test defined in this document consider the severity or classes of the environmental parameters provided for by EN 50125-3, but those test requirements remain applicable even if the severity levels requested by the customer differ. In the scope is repeated that this document applies to railway signaling and telecommunication trackside equipment. This document does not cover signaling and telecommunication equipment mounted in vehicles. This document covers the type testing phases. In particular, this document intended to define test requirements with related performance acceptance criteria, considering only the environmental conditions stated by EN 50125-3 and considering the severities of the environmental parameters herein defined. Moving to the content, the fourth clause shows the relation between the environmental condition defined in EN 50125-3 and test requirement defined in the document. For the environmental conditions marked with an X, test requirements have been defined in the document. In the informative Annex A, inserted for a better understanding of the document, is reported the analysis of the environmental condition defined in EN 50125-3 and their influence of the functioning of the EUT, the equipment under test, and also the relation with the test requirements for type test defined in the document. As you can see, in this version of the standard, no test requirements are defined for wind, fire protection, and power supply, and the reason is explained in the Annex A. So, for example, for fire protection because fire protection is already taken into account by the safety standard. For example, EN 62378-1 for IT equipment. And for power supply, it's impossible to define clear test requirement because voltage value, voltage variation, frequency variation, possible dips, etc. are different considering European countries or the owner of the infrastructure. In clause 5, we specify the test requirements divided considering the type of the test. So we have insulation test, temperature test, humidity test, vibration and shock test, EMC test, test for protection against water and dust and sand ingress, solar radiation test, and test for protection against external mechanical impacts. This is an example of the test requirement for the dry test. So a table explaining the test, what is the initial measurement to do, the preconditioning phase, test cycle, and then the recovery. And the figure showing the sequence graphically. So very easy to follow and to perform the test. Sorry. Then clause 6 explain the documentation needed for the execution and the relation of the type test. So the type test specification, the type test report, and the type test compliance summary sheet, a sort of data sheet related to the type tests. And some annexes are inserted for a better understanding and a better application of the document. Now I want to talk about the use of the standard. There are mainly two ways to use this standard, this considering the needs of the reader. If I want to cover, for example, a specific environmental condition, what test should I perform on my equipment? So starting from the environmental condition and reading the information in Annex A, I can clearly understand what test I have to perform to cover all or part of the effects that the environmental condition can have on the equipment. Or, if I want to perform a full type test session on my equipment, what test should I do? In this case, starting from the equipment installation condition, with the help of the Annex D, is possible to identify the correct test requirements. So, considering the second way to use the standard, in the next slides are inserted some examples of application on a computer-based interlocking, a field element controller, always connected to the interlocking, and a railway signal. So computer-based interlocking to be installed in a railway station with continuous climatic control. In this case, we shall apply insulation test, no temperature and humidity test because the temperature is inside 15 and 35 degrees and the relative humidity is lower than 85%. Furthermore, no vibration test because are negligible. Of course, the EMC test. And the other tests are not applicable because the equipment is to be installed inside a building. Field element controller to be installed in building or shelter near the rail from 1 to 3 meters from the rail. Always insulation and EMC test. In this case, temperature and humidity tests are applicable because can be installed, the equipment can be installed in building with no climatic or temperature control. Considering the distance of the equipment from the rail, the vibration tests are applicable. And the other tests are not applicable because the equipment is to be installed inside a building. Railway signal to be installed on a pole near the rail. In this case, all tests shall be performed on the equipment because it is exposed directly to the external weather. It is required an IP54 to prevent the ingress of water and dust and sand. Shall be evaluated the effect of the solar radiation and shall be verified the mechanical resistance of the enclosure against mechanical impact. So these are only example with and I try to insert some value, but the value that you have to use is considering the customer request or what is requested, considering the environmental condition stated in EN 50125-3. So in a very short time, I've tried to condense a lot of concept, I know, and so I understand that some of you may still not have it clear, but I still hope that I've transferred some important information to you so that you can then be able to go and analyze it further. Thank you again, and if there are any questions, I'm here to answer them. Thank you.
Thank you very much, Dennis. In fact, we are collecting some questions. We have collected at least 3, but maybe a 4th is coming from the chat. So the first question for you is, will this standard be harmonized under interoperability directive?
Okay, so for the time being, no. This is because the standardization request started from the needs of the market and not from the European Commission. In any case, in a few years after companies have begun to use the standard and then the standard can be considered mature enough, it is possible that will be integrated within the standard referred to the directive in the related official journal. But for the time being, no.
Second question, is a good knowledge of type testing required to apply and understand this new standard?
So, certainly a person familiar with the type testing and its execution has an advantage in using the standard, but considering the input received from our subcommittee, the SC9XA, the standard was written so that it can also be used by people unfamiliar with the testing. All the values included in the standard and all the relationship between testing and environmental condition are explained in Annex A, so that they can be understood by everyone.
Wonderful, thank you. I will try to do my best next time that I visit you, to understand practically what it means and if I'm able to do it by myself.
Yes,
but
yes.
This is just a joke. Next question.
You can try to perform
yes,
the test.
Yes, with pleasure. Thank you. Thank you for the invitation then. Another question is, I see a cross for EMC test, but you said that EMC tests are already described in EN 51214. Can you explain?
Okay, yes. For EMC test, all EMC tests are covered by EN 50121-4. So in 50121-4 is the product standard, and the product standard that recall the basic standard, the 61000-4 series. So for this reason, in our standard, we don't specify DMC test, but in this case, in our standard, we recall only the 50121-4. So I think that I answered to your question, but for EMC test, we in our standard, we don't introduce new test requirement, but we leave to the existing standard, the 50121-4, all the test requirement for the execution of the EMC test in a signaling or telecommunication equipment.
Yes, but for maybe I have understood that you put a cross in one of your table about EMC, but you have to refer to 50121-4. But okay, maybe it's just a additional cross in the table.
Yes, exists the cross in the table.
Yes,
but
so
only because we refer the 50121-4 is to we don't want to leave this point. we consider at this point, but we immediately refer to the 50121-4. We cannot insert a test requirement for EMC requirement because we have an harmonized standard for EMC.
Okay, I hope that this is answering who has raised the question. Another point is, why do you do humidity tests similar to 50155? The trackside equipment won't have the strong temperature and humidity change while passing through tunnels?
Okay. So the humidity test, for now we have planned 2 cycles of dry test like EN 50155, but the cycle of the EN 50155 is not to cover the passage of the train in the tunnel. The 2 cycle of the test needs to understand if the equipment can be needs to evaluate the properties of the equipment if is capable to maintain his functionality considering the breathing or the absorption effect due to humidity. So you have this cycle of with the high level of humidity and the temperature that go down, fall down, and rise up, and this passage of this change of temperature can induce a breathing effect, and but is not this temperature rise or fall is not related to the passing through the tunnel of the equipment. But I think in order to answer to your question, yes, the humidity test is very similar, but I think the same of the 50155 2 cycle of damp pit test.
Okay. Another question is this standard specifically addressed to signaling equipment, or are also other trackside equipment covered, like maintenance sensors?
Okay, for the time being is under the SC9XA, so is cover the same equipment in the scope of the 50125-3. So if usually you apply the 50125-3 for your sensor, and if you usually apply the 50121-4, for example, for your maintenance sensor, so you have to apply after, but is volunteer, is a standard, is not an harmonized standard. Is are volunteer the harmonized standard, so is more than volunteer, this is standard, and but yes, for the time being is applied on signaling and telecommunication equipment, but can be applied, for example, considering the customer needs, and the customer can insert in the specification for a maintenance sensor that shall be applied our standard to verify that the equipment fulfill the environmental conditions stated in 50125-3.
Okay. Another question also regarding some comparison with the 50155 is regarding the dry heat test. Why is the equipment switched on permanently in 50736? 736, yes. In 50155, the equipment isn't switched on permanently. Example, during the temperature ramp and stabilization time.
Yes. Okay, it's a choice. For 50155, because usually in 50155 they consider that the train is switched on and off and stop and then restart, etc. So you have a lot of switch off and on. For signal intercommunication equipment, if you if you develop a very good product, you switch on your product, so you forgot of your product in the field. So the product is always switched on. It's not you don't have the switch off and on as for the onboard equipment. So for this reason, we consider the equipment always switched on, because is the real situation is much similar to this condition. It's very difficult that you have for signaling equipment is always switched on. You don't have to switch on and off like for a train, I repeat.
Okay, thank you.
But for the train, the writer of the standard have taken into account this condition to switch on and off, to switch on at high temperature, etc., etc.
Okay, very last question, at least for the moment. Maybe we will have something else in the Q&A session after the second speaker. Are there specific duration and thresholds defined for shock and vibration test for equipment installed 1 meter to 3 meters from the rail?
Yes, yes. We think about a test sequence. We insert a test sequence with an initial frequency to identify the initial frequency response of the equipment in order to verify if exists resonance frequency or not resonance frequency. Then we have like a fatigue test with the level always considering the level of the 50125-3. Then we insert a shock test. And at the end, you have the final verification of the acceleration of the equipment. So, and for equipment installed from 1 meter to 3 meters, considering the provision of the 50125-3, yes, we have inserted the vibration test.
Thank you very much. Now it's time to give back the floor to Lutz in order to continue with the second speaker and the question later on if there is something for you, Dennis. Thank you very much for your presentation and all your answers.
Thank you to all for your question.
Yeah, thank you very much also from my side for this interesting presentation. Coming to the next presentation, it's from Berlin. It's from Markus Reimann, Senior Expert at MBSA at Signal Deutschland. It's a member of RailS, our friends in Saxony, as well as from our regional cluster, Transport, Mobility and Logistics. In Berlin and Brandenburg, Markus is a senior expert in model-based systems engineering at Signal. He has about 14 years of experience in systems engineering. About 8 years he was developing embedded jet engine control systems for the aviation industry, and since 2018 he is developing generic railway systems. At Signal, Markus is a project lead for projects supporting for DB InfraGo initiatives like Digitale Schiene Deutschland, in English, Digital Rail Germany, for reference CCS architecture, RCA, and for system pillar and innovation pillar. Markus, the floor is yours.
Thank you, Mr. Hübner. Hello, everybody. Hope you can hear me, and I hope you will also be able to see my screen shortly. All right, so now you should be able to see my screen. Please let me know if that's not the case. Great. All right, thank you very much, first of all, for the invitation to this webinar, to Mr. Hübner, and also thank you very much for the kind words. And also thank you very much to Mr. Galli for the presentation on the type testing on actual hardware, because for the presentation I'm going to give to you, this is going to be a kind of a change of realm, because or a change of level of abstraction, because my presentation will be more about the development of the entire generic rail system. Let's say we're talking about there on the domain of requirement specification and and modeling of those systems. So it's more like of these concepts like divide and conquer, where systems are defined and subsystems are derived from the system. So my presentation is about the development of standardized interfaces, and this most or more specifically in the realm of the development of complex CCS systems by the means of a model-enhanced approach. And complex CCS systems, I guess everybody's familiar to that term. It's about the control and command signaling systems. So it involves, for example, the light signals and the like that we already heard of in the previous presentation. Let me give you first a brief overview what I'm going to talk to you about. First, I give you a first introduction of who we actually are at Signon. Then also a report of our experience and our views on what the current goals and challenges for the future railway are, and also some method and development approaches, how we see it feasible to overcome those challenges and achieve the goals. Later on, I'll give you a presentation of one specific aspect of those standardized interfaces by the means of showing you the standard communication interface, STI, to some detail, of course, not all of it. That would be too much for this scope today. And in the end, I'm going to show you our conclusions that we derived in our developments in the mentioned projects. So briefly about us, Signon. Thank you again, Mr. Hübner, for the nice, kind words already, where you presented myself. So I keep this a bit shorter here. So my just as a takeaway, I'm the senior expert for MBSE. So it's about mainly systems engineering. So really the domain of developing complex systems, and I have about 14 years of experience in that domain. We at Signon, we are approximately 280 employees, and we are an engineering service provider for the railway industry since roughly 2010. And yeah, since then we worked roughly about 6,000 projects worldwide, and we are mainly involved in the planning of implementation projects, but also in the development of the railway system of the future, what this presentation will be more about. But also we develop specific software solutions explicitly for railway. Our areas of expertise rely in these three areas which I'm showing to you. So it's about planning, engineering, but also technical consultancy. Moreover, we are really the main focus is on the planning and the engineering part, where we are deeply involved in also the digitalization of the railway industry. For example, when it comes to the establishment of databases of real infrastructure elements out there in the field of we call it in German Bestandsdigitalisierung, where we have solutions out there where we have sensor systems or video equipment mounted on a train, and we record the tracks while passing through over the trains, and are able, for example, then to derive the digital information on where, for example, signals out in the field are actually mounted, because sometimes, I guess most of you already experienced that there is a deviation between what the plan says and what reality says, and that's an issue in some areas in the railway, and we have such solutions in place, for example. Yeah, our customers really range from infrastructure operators via system providers, and also construction companies. But yeah, as you can see, some familiar names are there, like Bahn & Noah, Siemens, Thales, Alstom, and the like. Yeah, that's about us. Coming to the topic of today at hand. So our views on the goals and the challenges of the future railway are as follows. So we see that the current system development in the rail or for the railway systems miss a real full standardization. So that manifests in high efforts on transitioning between neighboring systems, be it a legacy system or be it just two neighboring systems. and also high variety on operational rules. I mean, I guess everybody is aware of that. Whenever a train is traveling through Europe, those trains must be equipped with different technology to accommodate the local and national train control systems, and also the rules on max speeds, for example, are just as simple as that, are very different across those countries. We also have country-specific interfaces, which manifest that in the midst of or lack of an overall architectural approach. So meaning that we have low exchangeability and extendability of the systems as such, and the components inside those systems, resulting in low robustness against version changes, and also a high dependability on the market. So for example, to the present day, the most of the systems are provided as a turnkey systems by system providers, for example, to the infrastructure manager. And if any of those components used in those systems are not supported anymore due to sheer market demands and market situation, then that's the case that the infrastructure managers have to deal with. And so it's not, the current systems are not very robust against that. Also, this high variety of interfaces we have also result in high efforts on safety assurance. So there's no generic way of doing a safety case, for example. It's really a case-by-case situation and for every system, and that results in high effort. Further, also the human operators, which are to the present day a key component, let's say, in the safe operation of the railway system, have limited automated support. And whenever we have degraded situations, the workload of those human operators increases significantly. In the best case, resulting only in operational disruptions. In the worst case, we have a real failure of the system and potential harm to human beings, which is definitely to be avoided. How to overcome that? What we see there is twofold. First of all, technical. Second of all, political or politically. So technically, we aim for exchangeable modules, meaning that we have defined functions which are purely derived from operational needs, and those are communicating via standardized interfaces. I will elaborate on the advantages on that one. We also want to enable the stepwise adoption of innovative solutions. So meaning, for example, just as a spoiler already on what I'm going to show you on the next slides, is that whenever a function or component is connected via standardized interfaces, the system itself doesn't really care what technology is used, for example, to locate a train or to perceive the environment of a train, as long as the communication across the standardized interface remains fulfilled. The subsystem providing this information that's communicated across this interface can be any subsystem, as long as it can also be any technology, as long as the standardized interfaces are fulfilled. Also, we aim for a high grade of train operation, high grade of automation of train operations, so up to the grade of automation level 4, which really means that no human being is involved anymore. Maybe you know intermediate grade of automation levels 2, for example, where we still have staff sitting on in the train and observing the correct operation of those trains. Also, it means that in terms of standards and norms that we would need for the actual certification then and type certification of those systems, we also need a so-called TSI input plan, where, for example, mainly for the CCS TSI or the OPE TSIs, we must cater for new functionalities that we need and for new operational rules that we need. That then would potentially also affect standard standards of the standard series like 51-6 to 51-9, for example. Second part, and the political approach to it, is that there's a European roadmap on sustainable smart mobility with the European Green Deal. This is summarizing several already existing initiatives to do this standardization of the railway system across Europe. in the Europe's Rail joint undertaking. And maybe you know some of those abbreviations here, but the RCA, for example, is the reference CCS architecture, which was now integrated into System Pillar, and which would taking care of the standardization of the, let's say, the development of the reference architecture in general that can be then deployed to the European countries. Okora, I mean, Shift2Rail, this S2R abbreviation here, did something similar and has it, yeah, they just with a slight scope of different, there was a slight difference in the scope of the two initiatives. Okora did something similar or aimed for something similar, but on the on board the train. And ULEX, for example, you might know is an initiative where really the standardization of the communication to actual technical field elements like light signals, points, and the like are standardized, and also the architecture of those are standardized. All those initiatives had commonalities, so they have been summarized in this Europe's Rail joint undertaking. And mainly there are two pillars which are there to strengthen especially the collaboration between the industry and the infrastructure managers. So one is the system pillar, which is taking care of the development of such a reference architecture in a overall and consistent and complete way, along with generic operational concepts, such that you don't find so many different operational rules across the European countries. And the innovation pillar is actually the part where you put things to reality. So prototypes are, or the feasibility of concepts and technologies are demonstrated in prototypes. And this is more closely going together with the industry here, the second part. So far about the challenges and the goals that we see and how we think we can overcome those kind of things. I want to briefly present you one of the generic approaches that we used, which is one aspect is related to the method in general. The other aspect is more to the system development approaches that have been implemented. So what we see as an essential is the model-enhanced approach or model-based approach. Which means that whenever you do system development, meaning the requirements management of the system, of the subsystem, of the components, of the system elements, all the elements you can think of that are involved there, you do the stakeholder analysis, context analysis, you have processes in place, and then putting all this together, you get the requirement specification out of it. So what we do, we put a system model in the middle, meaning we have a method, notation, and a tool going all along. And we can achieve by doing so improved quality, because notation means that we reduce the space of interpretation for any requirements out there, because we have a formal notation which is standardized and everybody has the same understanding. So we reduce the potential for interpretation of requirements, which, as some of you might aware, that this usually causes also many iterations in the system development. We have in the system model technically connected artifacts in a single and centralized source of truth. So everything is inside the system model. That's the idea. By doing so, we see shorter development times, since a system model goes along with the proper tool, and the proper tool allows it to do decent impact analysis. And so whenever solutions are developed and problems are analyzed, that can be done because everything is technically connected. So whenever you change an element, you have to look at the connected elements. And also things like verification of the system requirements, and also early prototyping can be done by a simulation, which is driven by the system model, but also possibly done inside the system model. Also, configuration management is approved, and also, for example, in the case of ULINX, test cases are developed, and which allows then easy checking, let's say, of in how far is developed systems compliance to the ULINX specification. And those are also publicly available. All in all, this results in smaller costs and shorter time to market due to improved quality and less development cycles. One of those possible development approaches that we used in RCA, for example, but also today in the system pillar, is the Arcadia methodology. It's basically a layered approach where the top two layers are about the problem understanding and the this one here, and the lower two layers are about the solution development. So clear separation between problem domain and solution domain. And what's indicated here by these nice little arrows is that in the end, the physical subsystem that manifests and that are out in the field should be able to be traced back to operational needs, to the most upper stakeholder need. And if that can be done, then probably there's a not needed redundancy in the developed system already. And so what does it mean? I mean, this Arcadia approach I'm showing here is purely operations driven. So whenever system development has certain system elements, they should be traceable back to operational targets and needs. We have high consistency because of this traceability, which is in the system model. We have everything based on function analysis that should avoid unnecessary redundancy. Maybe you know that in traditional historic 180 years old system, potentially 180 years old railway system, we sometimes have some components which we cannot get rid of because it's just too hard to make a safety case to ensure that the system, the modified system, is still as safe as the previous system. And that's sometimes hard to really elaborate why some elements exist because it cannot really be traced back what kind of functions they fulfill. And we have a single source of truth, which then allows us to have everything in one place and everything technically connected and also fully customizable output is possible. So whenever it comes to system requirements, most of the industry uses textual requirements, and those kind of things can also be generated out of the model. And also all domains are supposed to be integrated. For example, when it comes to traditional railway systems, I mean, electronical, I guess, are the most widely distributed. But also when we think about news railway systems, they are mostly digital. So then we also have to think about communication platforms, network architecture, computation platforms, and usually these are different domains. I mean, a railway expert usually doesn't know something about the computation platforms and network architecture, but that's clearly a need, an essential need that we have, and this can be also integrated in the system model. That's all about the generic methodological approaches, but coming to the more specific system pillar, RCA, specific development approaches are the standardized interfaces and the abstraction layers that have been introduced there. So what you can see here is that from top to bottom, that's a kind of an abstraction going on in the breakdown to more specific things. So at the very top, we start with an operational plan, and we end up at the very bottom controlling specific hardware elements, for example, points to be switched to left, right position, and the like. But what's the good thing about it is we have different standardized interface introduced here, these SCI OP, SCI CMD, AO, AD, SCI XX, for example. So an operational plan, for example, is transferred to via the SCI OP to a so-called plan execution component, let's say. And from this operational plan, certain track allocations and track paths are extracted. And for those tracks needed to realize a certain operational plan, so the operational plan is just telling when the train is going from A to B. And those necessary tracks extracted out of this operational plan are then transferred via the SCI CMDs to a so-called safety logic, where an abstract representation of elements in these tracks are evaluated if they allow safe passage. And those abstract representation of trackside elements, trackside assets, so to say, are, for example, commonalities that all the elements have in common. For example, points at level crossing. They are switched. They allow drivability. So I can only drive along a track path whenever the point is in the right position or whenever the level crossing is closed, for example, or deactivated or activated. And meaning we can judge the safe passage already on attributes, simply on attributes. And we call it drive protection section group. And then after positive confirmation that the passage is safe, then those drive protection section group, which contain those commonalities, common attribute of the field elements, are then broken down into actual hardware, because then it comes to the object aggregation via the SCA-AO, and from then on we can then say that to realize a certain drive protection section group, we then have to switch certain points and certain level crossing and also certain light signals, for example, all the elements you can think of. And here happens then the in the fixed object transactor, the relation of the abstract object to the topology, when we then really say, okay, this track path includes 3 points, 1 level crossing, and they have to be switched. And then, for example, the very low end, the things we know already from Ulinks comes into play, where specific field elements are controlled. And here, the only thing to notice is that via the SCI-XX and SCI-FS, so it's the Ulinks field element subsystem interface, the only abstraction here that's done is that the generic behavior of all those field elements is separated from the specific field elements. So this generic behavior is more about initialization and booting. So whenever you want to have those elements available, you the booting and the initialization of those elements is identical. Doesn't matter if it's a level crossing, if it's a light signal, or if it's a point. But once that's done, then the SCI-FS is used, which is then transferring field element specific commands like point switching and the like. But on the same way, like I described from top to bottom, also from bottom to top, this information is then aggregated back together. So from certain status of field elements, it's aggregated to certain to statuses of the entire track path, up to the status of drive position groups, drive protection section groups, sorry. And also this all then is aggregated into a certain status of the operational plan, because in the end you want to know, are your trains on time, where they are not on time, where special means have to be taken into account to dispatch trains manually, for example. So much about the development approach used there for system pillar. Some examples on Ulinks. Specific examples are, for example, in the I mentioned in the system model explanations already that some simulations are easily done with the means of the system model, and you can see that here on the left-hand side. So, for example, when it comes to the communication with stakeholders, or when it also comes to the derivation of test cases, what's possible to do is that the features which might have been introduced with a new version of, for example, Ulinks like light signal controller, they can be easily tested and validated. Sorry, validated. It's important. Validated by the actual stakeholders by having one of those simulators where you can then say, I introduce a night situation. I introduce that my light signal is now having a lost connection, and how does it behave, and all these kind of things that can be experienced with a simulator like that. And also current Ulinks subsystems out there, as they have been presented in the last InnoTrans, for example, are things like the feed element controller I show you here on the right hand side, and also the train detection system like axle counters and the like, and the field element Anschlusskasten. Nice German word. Field element Anschlusskasten, something like a field element connection device, something like that. Yeah, but I hope you get the idea of the examples. So coming to my conclusions, for the development of standardized interfaces, we see twofold approach. And twofold approach is that we see a great benefit from having abstraction layers, for example, where an abstract object representation allows us to have standardized interface, meaning that the core functionality is always the same. So we don't depend on technology. Different technologies can realize same core functions. And that's done by, for example, abstract object representation. Remember, example given is that drive protection section groups represent points or represent level crossings. Doesn't really matter in terms of, I want to move one train from A to B, then that's done with this abstract object representation. Also, standardized interface are allow then the modularized architecture. So meaning as long as we fulfill the specified communication across an interface, the subsystem connected to it can be exchanged easily. And also, as I mentioned already, the emerging technologies can be easily enabled because example I mentioned was the perception one, where we don't really care about the perception technology or localization technology as long as the functions are fulfilled. This goes hand in hand with the model-enhanced methodologies, where we see highly consistent architecture due to a system model. We can see shorter turnaround time, and we have full traceability from physical phenotypes and subsystems up to stakeholder needs. And also we can enable early prototyping, as I showed you with the ULinks simulators, and also with test case development, for example. I mean, all in all this what I showed to you is still in an early development phase, right? So I mean, there are only a few deployments. So the only few deployments we have are from ULinks. The other areas about the other standardized interfaces are in the concept phase or in the phase of writing system requirements, actually. But we see the standardized interfaces fit for sustainable system architecture. Along with that, we also see that the model-enhanced methodology fits quite nicely to the various to manage the various level of abstraction, which again introduces complexity, right? Because I mean, the current present railway system is already quite complex. The abstraction layers also introduces some complexity. But to be fair, that's really not a game changer because the systems we are dealing with are complex already. And last but not least, we also see that we can accommodate with this kind of model-enhanced methodology the high innovative pressure. So especially when you think about concepts like changing from track-centric concepts to train-centric concepts, like moving block systems, for example, then you see that we need new technology to realize that, because we need to have real-time localization, which today is still a big issue. And other things, of course, there are other technologies needed. Yeah, and that's really it. Thank you for the attention so far, and really looking forward for your questions.
Yeah, thank you very much for your interesting presentation. And I switch over to the question slide. And for the moment, I have two questions there. The first is, what is the deployment status of standardized subsystems? For instance, RCR system pillar ULinks. I guess you already mentioned some of these points in your presentation.
Yeah, some of the points I mentioned were that, I mean, I implied that those kind of things are actually already a little bit, there are not so many deployments, let's say. So for RCA and system pillar, there's literally none. I mean, system pillar is the correct term because RCA is fully integrated in system pillar. But for ULinks, for example, we have some where, especially Bane NOR in Norway, implemented some of the ULinks subsystem ULinks specified subsystems. That's the correct expression. But also we have, for example, in now for the axle counters, I think the SMTF also tendered ULinks specified or ULinks compliant train detection systems, for example.
Mm-hmm. And what is the timeline, expected timeline to get more deployment of that standardized subsystems?
Oh, I would say it depends really on the country, but I think for Germany it would be really 2030, I guess, where some of the highly intense used corridors are modernized.
Yeah. Coming to the second question, what is your estimation on how the requirements management will evolve in the light of model-based systems development?
Yeah, that's a big topic still, because as I mentioned, I mean, usually in development of complex systems, we have textual requirements, and that's for good reason, because they must be legally binding. They are part of contracts that are fulfilled, and sometimes those contracts end up in front of the court, right? Where one party of a contract didn't really fulfill the contract, and therefore it's always a little bit tough to change the way of specifying things. But I think in the long run, it would be ideal to really get rid of the textual representation in general and just exchange models. And in some of the projects we were participating in, that was already the case, where, for example, the system level, where you remember from Arcadia, the problem domain, all these requirements on the system level are fully described in the model. This model is handed over to the suppliers, and the suppliers are then developing the subsystem solutions against that, for example. That would be one way. And you might also find historically similar developments, for example, in the requirements management, where there's already a commonly agreed format, the REC-IF format, which is an exchange format for exchanging requirements databases. And that can be done across various tools like TORS, Polarion, and the like. And I would see really something there for the future where the same happens with models. But I guess that will not happen in the next 10 years, or maybe in 10 years we are there. I don't know.
Yeah. You mentioned your engagement in programs developed by the Euro-Israel Joint Undertaking. I guess that would be interesting for sure also for other partners, for other companies, especially also for small, medium-sized enterprises to get involved in such programs in order to get some funding and can bring their innovations into such solutions. I guess it would be very interesting. To the audience, have you got some other questions? If there is one question left, please raise your hand and open your micro and raise your question for the second presentation as well as for the first presentation. That seems to be not the case. If there is one question, you can continue to raise your hand or put it into the chat. For the moment, thank you very much for the presentation again, and I will proceed with the next slides. There are some information from ERCI activities, and that might be also helpful for you. And at first, I kindly ask you to give us a short feedback on this webinar by opening our feedback questionnaire with only some questions. You need only 2 minutes to answer it. It is a kind of evaluation of the presentation, and what is very important for us are your suggestions for future topics which we can deal with in future ERCI webinars. I already put the link into the chat. Coming to the success project, that is a project where some of these 17 ERCI clusters are involved in. It is to support European SMEs of the rail supply industry in successfully applying to public procurements in USA, Canada, and Norway. And this project has elaborated some weekly Tenders Watch newsletter in these 3 target markets, and you will be able to subscribe to these newsletters. It is free of charge. If you want, you will have a good overview on the ongoing tenders, open tenders, and you have to visit, you contact as well Ms. Vescu or Ms. Ruiz de Luisaga or Ms. Esperu in order to get these newsletters, and this project also gives you some support to find good partners when you are trying to apply for such a tender. And please contact the project. You can contact Irina, for instance. She is from DTEC Fair. DTEC Fair is the project coordinator, and she will give you some good advice on that. I will put the hyperlinks of this slide into the chat afterwards. Then I'm continuing with our STARS B2B meeting platform. It's coming from the former project STARS. And the main goal was to matching companies from the rail supply industry with solution providers that support them in adopting advanced technologies to improve products, services, manufacturing processes and organization. And if you want to find a right partner, a good partner for these topics or also for other topics, you might arrange a meeting with one of the other or more of the other platform participants at any time. The only precondition is that you create or update your profile I already said the link I will put into the chat later on. Then there was 2 questions regarding the recording of this webinar. It is recorded, and in some days, maybe tomorrow, maybe on Friday, maybe on next Monday, the recording will be available in the YouTube channel of the STARS project, and there you find also previous ERCI webinars. Coming now to one project that is led by ERCI itself. It is Leader 2030, and the rest I think is good that Guido Angarani, the operations director of ERCI, can explain to you at himself. Guido, it's your floor.
Thank you, Lutz. Yes, I will be brief explaining or just giving some elements about this Europe's Rail project called Leader 2030. The acronym means Learning for European Autonomy to Deliver Europe's Rail in 2030. What we are examining and what is our aim in this project is to give Europe's Rail some element about potential disruption on material, components, and raw material and components. Next slide, please, Lutz.
Sorry.
So what we are looking at is a potential problem of out of stock while the project are delivering what is foreseen in 2030. Next. So just to take an example of the lesson of Friedman on the pencil, it's impressive to learn that the pencil is composed by elements coming from 10 different countries, and you can already imagine which could be the difficulty in the future when instead of a pencil we are talking about a railway system or subsystem. Next slide. So for this, Europe's Rail has issued a tender, a call for proposal, where the keywords was supply chain, need of the future, and absolutely terms like disruption and raw material are central of this call. Next slide. So in this slide, you see that the main difficulties that we can raise, we as railway environment in the future, we can raise in 2030. So first of all, we have those elements which are lacking and used in several applications. The railway is not the only one which need raw material or components. We have competitors, so it's a question of priority in terms of elements that will compose the future system, but we have also to consider problems and difficulties due to climate change. And in the bottom right part of the slide, you see the area of the world where the climate change risk to have some negative impact in extracting materials or the production of components, electronic components in particular. Next slide. So therefore, we have built a consortium with 4 partners. ERCI is the leader of this project. In particular, then behind ERCI, DTECFER is the coordinator of the project. But we have also the Technological Center Rheinlanium in France, JKZ, which is the cluster specialized in mines and raw material based in Saxony, and Technopark Istanbul, which is able to bring the elements for considering the intersectorial needs in order to see that the railway is well represented, but as potential competitors for the use of raw material and components. Next slide. For the time being, we are in the first phase of this project where we are studying the past to identify alerts for the future. This is the starting point. Next slide. And in order to do this, we are asking to all the companies who are wishing to answer to a European consultation on disruption in order to collect information which will be useful for then try to build policies for the Commission through Europe's Rail. So you see the QR code for the different consultation in different languages. So this will be used to consolidate our knowledge. Thank you for answering. Each answer is certainly an additional element in our work. And we are doing this not for us, but for you, because if you have already seen some disruption, maybe this can be avoided in the future, or we try to find some contribution to Europe's Rail in order to influence or try to have a voice in the trades agreement of the future. So next slide. So thank you very much for your attention, and I give back the floor to Lutz.
Yeah, thank you, Guido. And I put into the chat the different language versions of the consultation for LEADER 2030. And these are the languages of the ERCI clusters. And if your language is not among these versions, for sure you can every time also use the English version. Thank you very much again. Coming back to the next ERCI webinar, and the webinar is dealing with seamless vehicle positioning in rail via GNSS and ultra-wideband sensor fusion. And just running with a registration link, for sure I will provide it you into the chat as well. And for sure, please do not forget also to send us a feedback to send us a feedback for this webinar and your ideas for future topics.
Excuse me, Lutz.
Yeah?
It seems that this link is not the right one. It's for the previous webinar. I checked it and it goes to the previous one.
So I will update it. Yeah, we will check this and I will send you the updated link in the follow-up email I sent out some days later. So. One word to say. I saw there was one question left or similar. Is it the right form?
It's concerning the form for the feedback.
Yeah, it's a form for the feedback. Yeah, maybe is not the right one. I will send you the right links. Yeah. All right. Maybe it's not the right form I sent out, and I will send a new version with a follow-up mail. Thank you. So we are in the end of our webinar now, and thank you for your attendance. Thank you for the presentations, and all the best for the future. And maybe we will see again at in 14 days and 2 weeks at Wednesday, the 13th of March. Have a nice day. Bye bye.